Hi and welcome to another mini lecture. Topic today is finding values of trigonometric functions from a point on the unit circle. So let me refresh your memory as to what the story was here. We are on a unit circle, which means the radius is 1. We are at some location. The coordinates are given. Those coordinates define a certain angle for us. That's the angle theta. So the picture that we have looks like this. We have the angle theta. This is x, this is y, this is 1. That is in case we are in quadrant 1. So in case you remember the definitions of trig functions from your high school classes, probably there they introduced it to you in the following way, that sine of the angle theta is the ratio of the opposite to hypotenuse. So that's a y over 1, which is just y. Cosine of theta is the ratio of adjacent to hypotenuse, and that is just x. And then tangent of theta, ratio of opposite to adjacent, that's how it is. Cosecant of theta is the reciprocal of this, 1 over y. Secant of theta is 1 over x. So hypotenuse divided by adjacent, and here is hypotenuse divided by the opposite. Then we have finally cotangent of theta, which is the ratio of adjacent to the opposite. Why is it that we define it this way? Because if we go to the second or third quadrant and such, we no longer have a triangle, right triangle to work with, but we still have the x and y's, and we can still apply the same set of formulas. So this approach is sometimes referred to as triangle trigonometry, and this approach is referred to as a circle trigonometry. They both lead the same place. I just brought it up in case you saw a different version in your prior class, so that as we go from one style to another style, it doesn't create confusion. So any of these problems, a point is given to you. So of course the first one is x and the second one is y. And they are set to the point set to be on the unit circle, which means that always x squared plus y squared is equal to the radius squared, and unit circle means the radius is equal to 1, so r squared is just 1. So if you want to verify to see your point is on the circle, like here you say 6 squared over 7 squared plus radical 13 squared over 7 squared. Well, what's that? 36, and this is 13, and denominator is 49, and that's of course 1, just verifying that we are actually on the circle. In any of these problems, theta is the angle, so wherever this is, so perhaps somewhere around here, we have the idea that this is like 6, 7, and this is radical 13, 7, and this is 1. This is the angle we are talking about, and you are facing three questions: what is secant, what is cosine, what is cotangent, or some other combination of these three functions. So what we have to remember is, well, how to apply this. And as I said last time, the very strong recommendation is that you try to make this thing second nature. That is, go through so many exercises that if somebody wakes you up 2 in the morning and asks you to calculate one of these things, you answer in 1 second with 99% accuracy. So to succeed in calculus 1 and 2 and 3 and future classes, you have to become very comfortable with these functions. Okay, so that was my sermon for these things. Now let's go ahead and so secant of theta. What is secant of theta? Let's write here. Secant of theta is 1 over x. Secant of theta, 1 over x. Okay, so always try to convince yourself of your answer and then enter your answers. So secant of theta, we have this is of course our x, this is our y, reciprocal of 6/7 is going to be 7/6, so 7/6. Cosine of theta, cosine of theta is just x, or you call it adjacent if you wish, so that's just 6/7. Cotangent of theta, ratio of x to y. So remember, cotangent of theta is x to y. That's our formula here. So x in this case is 6/7 and y is radical 13/7. And 7's cancel. I have 6 over radical 13. That is a good answer. It doesn't say anything for us to rationalize, but in case you want to go a step further, you could multiply by radical 13 and then divide by it as well, in which case this becomes 13. But since nothing is required, this is just as good. We might just stop here. So here was 6/7 and 6 over radical 13. Remaining problems are just the same, except that, as we said at the beginning, the reason why the circle trigonometry is introduced is that we are not limited to the first quadrant. We can go all around and apply the same idea. X and y always have meaning for us, even though a right triangle is not going to be meaningful that much in the second or third or fourth quadrant. Uh, but again, if you learned it in this different style in high school, just go ahead and apply what you learned. So here we have, let's draw a quick picture. We have x some positive number, y is some negative number, so it means we are somewhere here. So just to have a picture, we are somewhere in this location. Our x is 12/13, our y is -5/13. The angle, you have a choice, going this way, that's fine, or going that way is also fine, except that second case the angle is negative. So cosecant of theta, what was a cosecant? Remember, that was reciprocal of sine. So always draw this picture for yourself in the first quadrant where you are most comfortable with. X, y, and 1. This is, let me call it alpha here. Sine is opposite over hypotenuse. Sine of alpha, opposite over hypotenuse. Cosecant of alpha is going to be reciprocal of this thing, 1 over opposite of 1 over y. So here is x, here's my y. 1 over y will be -13 over 5. Tangent of theta. Tangent, let's just refresh our memory. How would we have written this thing perhaps in a prior class? We would have said opposite over adjacent. So y over x in this case is going to be, so y over x would have been -5/13 over 12/13, and the ratio is -5/12. So this is -5/12. And sine of theta would have been, of course, sine of an angle is the ratio of its opposite to hypotenuse. It's just the y. In our case would have been -5/13. Side remark here is that these numbers are not all that accidental. We have 5, 12, 13 is one of those magical triangles with all the sides being whole numbers and this being a right triangle. So you know of the other one, the so-called 3, 4, 5 triangle. Well, there's a whole string of these things. There are infinitely many of them. And one of the prior lectures, I told you that a very interesting topic is try to find all of these things. Makes for a very interesting project, not directly related to this course, but there's some other course called number theory, where people are kind of fascinated by presence of whole numbers in our equation. So 3, 4, 5, everything's a whole number. 5, 12, 13, everything's a whole number. This one wasn't, like 6, 7, and radical 13. That is, there's a radical there. This one skips the radical. So anyway, this is an interesting topic, but a side issue for our course. If you are interested in mathematics, you want to perhaps read about it or write an article about it. Okay, another example, minus 3/5 minus 4/5. Again, remember this is x and this is y. Cosine was just x. Again, if you get confused by a prior class, just draw x, y, 1 in the first quadrant. This would have been alpha. Ratio of adjacent to the hypotenuse would have been your cosine. So here is just minus 3/5. The only thing that is happening here is that our angle, and the angle is opening in the third quadrant. So we are here somewhere in this location. That's why we are going through this trouble of circle trigonometry. Like with this kind of an angle, what kind of a right triangle do you want to define? It's possible to go that way too, but just justifying why this approach. Tangent of theta, why would have, how would have let's see, cosine of tangent. What was tangent? Previous definition of it, opposite over adjacent, which is just y over x. And in this case, when I divide by x, what do I get? Minus 4/5 divided by minus 3/5. These problems are such that these denominators are always the same, and of course minuses cancel and I get 4/3. Try to get some familiarity that here our cosine is negative and tangent is positive. So these are good things to remember. In each quadrant, the sixth trig function, what kind of a sign do they have? Are they positive, negative, or what? So let's quickly go through this thing. Side remark, otherwise these problems in this section are all the same. Let me just answer this. Cosine, secant of an angle is just the ratio of hypotenuse to adjacent, so reciprocal of x. So our answer is simple here, minus 5/3 reciprocal of this x, so 1 over minus 3/5 is just minus 5/3. So what were we talking about? Well, let's go one function at a time. Sine of the angle. As my angle goes from first quadrant to second quadrant to third quadrant to fourth quadrant, what is the sign of it? I'll have a bit of a hard time distinguishing between these two words, sine versus this sign. So maybe I call this thing the plus or minus of the number. Well, what's the plus or minus of a sign in the first quadrant? Here is positive, is that right? We go to second quadrant, since it's just y, still positive. third quadrant my y become negative, and on fourth quadrant same way. So sine, and also of course it's reciprocal, which is 1 over sine cosecant of theta. uh, the pattern of it is this way. How about the pattern of if we are dealing with cosine and of course secant? They are going to have same kind of a pattern to themselves. They go with x, is that right? So this was with same sign as y, this is same sign as x. So first it is positive, you go here is negative, here is negative because x is negative, here x is positive. So that's how these guys go. Finally, let's go after uh, tangent uh, and cotangent of theta, which is going with y over x or x over y, uh, either way. So the ratio of these two is positive here. In the third quadrant it's also positive, just like here it turned out to be positive. Here x is negative but y is positive, here y is negative but x is positive. So the signs are like this. So for sine or cosecant, plus plus minus plus. For cosine and as well as secant, plus minus minus plus. For tangent or cotangent, plus minus plus minus. So you want to practice these things to become comfortable. Okay, I think we just have, what else we have? That's it. Okay, so let's a point on the unit circle is given. We want to find the 6 trig functions of the ray that connects from the origin to that point. That's how our angle is defined. And the 6 trig functions are very easy. Sine of theta is just y, cosine is just x, tangent is y over x, cosecant, secant, and cotangent will be the reciprocal of these quantities, so they are easy to find out. Okay, until next time, good luck and God bless.